Okay, this video will do an inequality that's a fourth degree polynomial. And it's one of the ones that we did in a previous section where it's a polynomial of quadratic form, meaning if you make a substitution for this one in the middle term, and make that letter u, then this will become a quadratic. And it's always the middle term that you're looking at, the middle power, the square, right? In this case it's squared, right? So whatever the variable is here. So my u is going to be x squared, and just substitute that in. So I'll have a u squared here and a u here. And I recommend just writing them out. If there's any of these that I didn't, I recommend that you just always do it until you're really used to it. So I write out what the substitution is. U is x squared. That just simplifies the way it looks, right? And you have to remember, your answer has to have x's in it, not u's. Your final answer. So I need to find the endpoints for the solution intervals. So I have to solve u squared minus 25u plus 144 equals 0. So if that factors, which I hope it does, I don't like to use quadratic formula for numbers that are 3 digits, you know. But if that factors, let's see, the factors would both have to be negative. Factors of 144 both have to be negative, and they add up to 25. So they obviously can't be the same because it's odd. 144 is 12 times 12, but that'll give me 24, right? But it's got to be close to that. So let me see. 12 is 4 times 3. So what if I did 3 times 3 times 2? Instead of 2 times 2 times 3, I changed a 2 for a 3. So 9, 18, and then I've got 6, 9. I think it's 18 and 9. Or 16 and 9. Oops. No, I was doing it in my head, just guessing. Okay, so it turns out to be, so 144 is negative 16 times negative 9. You know they're both negative because the middle term's negative, and those add up to 25, so that works. But go through and check it anyway. You know, do this every single time because you want to know for certain that you did this right. U times u is u squared. Negative 16 times negative 19. Just take 16 times 19 on your calculator if you want. You get 144 minus 16u plus, or minus 9u. Minus 16 minus 9 is minus 25. So that checks out. So I know what my u is. My u is 16 and 9. But u is not really what I wanted. I wanted to know x. So what I did here is I could have just figured out the u's first and then said x equals whatever the u values were. But I just decided to substitute x here, or the x squared here. So remember the u is x squared, so I just put the x squared back in. And you'll notice these are both difference of two squares, so they both factor. The first one's going to be x minus 4 times x plus 4, right? They factor into conjugates. The second one's going to be x minus 3 times x plus 3. So they came out pretty simple. That's nice, even though there's 4 of them. A fourth degree polynomial will have at most 4 solutions. The only time it has fewer than 4 is if a solution repeats. So if in the factoring you have like the same factor occurring twice, right? That's a fundamental theorem of algebra. That's if you allow for complex numbers. So I got these 4 endpoints. That means I'm going to have 5 intervals. And they're all open dots. Why? Because it's the original is greater than 0, not greater than or equal to. So those are all hollow dots. And now I'm going to try some test points. I'm going to guess I used, just going left to right, -5, -3.5, 0, 3.5, and 5. What do you want to bet I use those? Yep. You could use slightly different numbers. It doesn't matter. But those are pretty easy ones to use. So I have to try 5 different sample points, and I try them in the factored form. In here would be probably the easiest, right here, because you can easily tell which one's positive and negative. You don't have to write out -5 in here. You can just see, oh, is -5 -4 negative or positive? Well, it's actually -5 -4. It's negative, right? And just list out the product of the positives and negatives and see if the result is positive or negative. So I just rewrote the equation that I want, or the inequality that I want, so that I don't like get it backwards or something. But I wrote it in factored form instead of the equation down here. I wrote inequality in factored form. Okay, so we're going to try -5. I'm just working left to right on my sample points. -5 gives me a negative times a negative times a negative times a negative. That's a positive. And I wanted a negative. Well, did I want to? Yeah, I wanted a positive for this one, so that's good. -3.5, I get a negative, positive, negative, negative. This is like when you really don't want to multiply these things out completely, because it's going to be a mess, and if you do it on a calculator, you're probably going to mess it up. There's a pretty high probability anyway, because of all the keystrokes. Anyway, 3 negatives makes the negative, which is not what I want for this one. 0, I get 2 negatives. That makes a positive, yay. And 3, I get 1 negative. That makes it negative, no. And 5, they're all positive, which is good, makes it positive. Now, you might start getting the impression that these intervals always alternate. Yes, no, yes, no, yes, no. That's completely false. They don't. If I make up the numbers in random, yeah, they will. But I can easily make up problems where you'll have a yes and then another yes right next to it, or a no and another no right next to it. So check every single one of them. Don't get lazy and kind of just assume it always makes certain patterns. Well, actually, that would be clever. It's just incorrect. Okay? It's not stupid. It's actually clever. It's just wrong. Okay, and so I shaded in all the regions that work. There's 3 of them. And so I need to, starting from the far left, which is negative infinity, working all the way over to the far right, which is infinity, I need to write these 3 intervals with unions between each of them. Right? Union, union, right? And that's what I get. And notice they're all parentheses. That's because it was greater than 0, not greater than or equal to 0. Okay, that's the end of that clip. Let's try, I think the next one is rational expressions, I think.